All right, so welcome back to another exciting day in mathematics. Whoop, whoop. Warm-up number 99 is on the screen. And you're going to notice on this warm-up, I introduced a couple more things now, if you noticed. We're getting into the pre-calculus area, so I'm giving you all the foundational stuff before we get to those pre-cal lessons. I mean, we've been doing pre-cal now, but now we're going to get more full into the pre-cal portion on the fourth quarter. So let's see how you do with that. And the other stuff is basically things that you need for today's lesson. So hopefully you've been doing the graphing for the top two. Yes? Yes, Mr. Q. All right. Copy that and go. What'd you do for number one, Briseida? -2 to 2 on the domain. -2, -1, 0, 1, and 2. How about the range? That is correct. So when we graph that, I've been giving you plenty of practice, so it should look something like this and something like this. Hands, have you got that? Yeah. Now, I did a soft introduction to this function 2 weeks ago because I wanted us to be ready for today. Let's go, let's go. So this is going to be kicking in today, but with funner stuff, yeah? All right. Let's go to number 2. This needs to be transformed according to this, but this 3 is in the way. I remember when we got to these, I said put a 1 here, and we can use the 1 and the 3 as a fraction, move it to the front. So our new transformation would be g of x equals 1/3 f of x plus 4 squared plus 2. Does that ring a bell? Yeah, some of you? All right. So with that said, our parent function, which is a parabola, is going to be moved to a new vertex. Starting over the new vertex according to that transformation. What's our new vertex? New vertex. Ivan, new vertex. Go. Help him out, Diego Rosas. Okay. Help him out, Diego Rosas. New vertex. -4 and 2. Let's go. Oh, that is correct. -4 from here and 2 from there. Say that again? Yeah, we've been reviewing for 3 weeks now. Okay, so then the general rule should have a negative here. It doesn't, it's a positive, so we take the opposite of that, and that's going to be our H, and then our K is right there. That's our new vertex. All right, and last but not least, before we move this parabola to -4, 2, what does this do to the entire function? It's not a negative, not a whole number, it's a fraction. What is that going to do to the entire parabola? Talk it over to your neighbor. What does that do? What does that do? Christopher. Very good. He said it shrinks it. Yes, compresses it. It makes it a smaller parabola. Yeah. And then we move it to -4 and 2, which would be somewhere over here and up. Something like that. All right, let's go to number 3. Once again, this is stuff that we've been seeing since 6th, 7th grade, but this is very key for pre-calculus. Ready? Here it goes. A to the -2, anytime you have a negative exponent, you send that to the either denominator or numerator. Since right now it's in the numerator, I'm going to send it to the denominator and change the exponent to a positive and put a 1 on top. That's simple. You're like, and that's all we do to change it to a positive? Yes, Mr. Q. All right. But what if, I know your brain is thinking, Mr. Q, what if it's already in the denominator and it's a negative? Where do I send that? Tell your neighbor, please. To the numerator. That is correct. Change it to a positive over 1. That is correct. So anytime you have a negative exponent, if it's in the denominator, you send it to the numerator, it changes to a positive, or vice versa. B. Any number to the 0 exponent is 1. That is correct. We've been hammering this in semester 1. Some of you are like, I forgot, Mr. Q. Well, get with it. Any number to the 0 exponent is 1. And I think I remember when we did this, I said 1 million to the 0 exponent is 1. And I just, you know, what do you call that in English? Hyperbole or whatever? Yeah. Anyways, let's go to this one. Distribute the exponent here and there. So we end up with 1. Oh, hold on. 1 to the negative 4 exponent over x to the negative 4. We have negative exponents. Tell your neighbor what to do with that. Then Valente will help us. What do we do with that? Valente. Jaden, help him out. Okay. Lorena, go. Anaya. Flip them and positive, yeah, so flip it, change it to positive, flip it, change it to positive. That is correct. Yeah, if it's in the denominator, we'll send it to the numerator. And vice versa. Ah. Number 4. Once again, all of this is pre-cal stuff, yes? Is it coming along pretty well? Yes? All right. Let's go to this one. X to the 3rd times x to the 5th is x to the 8th, which means 3 plus 5 is 8. Well, if I was to ask you to go from here to here, you know what to do, yes? So, tell your neighbor what to write this if we went backwards. Tell your neighbor what to write. Juan, go. Delilah, help him out. Okay, so here it goes again. I'm going to go a little bit slower. X to the 3 plus 5 was x to the 3 times x to the 5. What was this, Diego Rosas? Say it again. 2 to the power of x. That is correct. Copy that. Let's go. Yep. All right. And last but not least, number 5. Graph the circle. Look at it. What do I do? Help me out. Briseida, get us started. Add 16. Group the x's together. X squared minus 8x, empty space. Y squared minus 4y, empty space, equals 16. Complete the square. Diego, Romo, go. To both sides. Negative 8 over 2 squared and negative 4 over 2 squared to both sides. So I end up with x squared minus 8x plus 16 plus y squared minus 4y plus 4 equals to 16 plus 16 plus 4. So the next step, I'm going to factor these and simplify this. This is 16 plus 16 is 32 plus 4, that's 36. Saying over the factors of this and the factors of this. So. All right, help me out with this one, Joel. Factors of this one. X minus 4 squared plus, how about this one? Y minus 2. Yeah, so square root of this, sine of the middle, square root of this, square root of this, square root of this, sine of the middle. That's how we get that. All right? So with that, we get a center of the circle. What's our center, Noel? Alyssa, help him out? Yes, 4, 2. What is our radius? Isabella. 6, that is correct. Or 36, take the square root. And now we can graph that. Let's see. Our center is at 4, 2. 4, 2, right there. 6 steps in all directions. 6 steps this way. 6 steps this way, and this way. And there you go. All right? All right, copy the agenda. And once again, put away all electronic devices. We don't need them. Appreciate it. Our agenda for today, warm-up number 99, rational functions. We're moving on today. And our home play, pages 394, 395, odds only. I'm going to upload that during lunch today. So our new module, you're going to find it's what? Rational functions. So make sure you go to that to get your home play for tonight. And I don't know if you guys noticed today I didn't pick up the home plate. I actually did a pop party instead. So that's what's going to happen now from this point forward. Sometimes I'm going to pick up the home plate, sometimes I'm not. And when I don't, some of those times I'm going to give you a pop party, just one problem. So if you do the practice, you should be ready for the next day, yes? Let's go. Let's go. Oh, yeah, we got this. Get a Cornell note ready, please. All right, y'all ready? Here we go. I can solve and graph rational functions. I can solve and graph rational functions. So in your Freyer model, what's our new concept for today? Rational functions. So write that in there. An equation that contains one or more rational expressions. Rational functions are an equation that contains one or more rational expressions. Like I said, today's session is going to go a little bit fast, so everybody go like this really quick. Bear with me, because it's going to go like, bam! Rationals. We've been talking about rationals since the beginning of the school year. Very never what word comes to mind when you hear the word rationals? Rationals. What word? Simple word in your own terms. Let's see. How about Anaya? What comes to mind? Rationals. Rational? No? Frida, help her out. Rational. Fractions. Let's go. That is correct. So equations with fractions. There they are. Copy those, please. Fraction, an equation. Another fraction with equation. Two fractions in an equation. Yeah, and notice now the fractions are not just simple fractions. They're fractions with polynomials. Oh, yeah. We're done with all the kiddie stuff. Let's go. So rational functions are an equation with rational expressions. Do I have a rational expression here? Yes. Here's my fraction. How about this one? Yes. How about this one? Yeah, two of them. There. All right. Students, rational functions, students. So with that said, why would these not be rational functions? Tell your neighbor, please. Why are those not rational functions? Why are those not rational functions? Why are those not, Fabian? So the first two are not what? Yeah, these two don't have equal signs, so they're not equations. How about this last one? It doesn't have a fraction, yes. So therefore, hashtag equation, it has to be an equation, and hashtag at least one fraction or one rational expression. All right, this video I'm going to upload in the afternoon, but I'm going to show you the steps that we're going to cover. It's only 3 steps. You don't have to copy it because we're going to go through the process. But if you need to copy it, go back to the video so you can copy the steps. They're simple steps. But let me show you the steps. Look up, please. First step, identify the vertical and horizontal asymptotes. You're like, oh snap, what are those? I'm going to show you today. Second step and third step we've been doing on the warm-up. Build an input-output table and graph the function. Have we been doing that? Yes, Mr. Q, thank you very much. You're welcome. Problem number 1 basically is done. On the warm-up, yes? Yes, Mr. Q. Just number 1, the asymptotes we need to cover. So before we go there, let me show you where we've been. Look up to the screen. You're like, oh, snap, we're going back to those. Oh, yes. Let's go. Tell your neighbor what each component does, what each parameter does to the function according to what our general rule says. What does each component do? All right, for the sake of time, good conversation. Let's start with K. What does K do, Jessica? Up and down. How about H, Isabella? Side to side, that is correct. Mr. Q, what does A do? It stretches it vertically or compresses it? Vertically. Yes, stretch or compress. Vertically. So what does V do? It stretches which way? Horizontally or compresses? Horizontally. All right? You don't have to copy that because you already have a bunch of notes for first semester with all that, yes? However, you do need to copy the new and improved rule. Ready? Ha, 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 ha. Copy that, please. New rule. Woo-wee. Copy that, please. So this is the new rule for today because we're moving into rational functions, but if you look at it, it's almost exactly the same as what we've been looking at before. Almost. Copy that? All right, let's see if you see what I see. Do you guys see that everything on the general rule is here? What's the only thing that we added? That we moved all of this to the denominator and we added a 1 because now we're going to be dealing with fractions. Are we there so far? But do we know what K does? Up and down, H, side to side, A, vertically stretch or compress, B, horizontally stretch or compress. However, today, H and K play a second role, aside from moving our function. Write these down with red and blue, please. H is our vertical asymptote, and K is our horizontal asymptote, and we'll cover what to do with that. H is our vertical asymptote, vertical, which means up and down. Horizontal asymptote, which means side to side, and I'll explain what that means. All right. Everybody done copying? Yes? All right. So since we're done copying asymptotes, eyes on the screen really quick. Here it goes. What are asymptotes, Mr. Q? Well, the easiest way that I can explain it is with Star Wars. Ready? You're like, what? Who hasn't seen Star Wars? Okay, detention. No, just kidding. So in Star Wars, there's this planet of bad people called the Death Star. Hence the name, Death Star. Anyways, on that planet, they are protected with an invisible barrier. So anything that comes close, they either crash into the invisible barrier or they have to pull away in order not to crash with the invisible barrier. That's as best I can tell what asymptotes are. Asymptotes are invisible lines that our graph cannot get close to or cross. I even wrote it in my own terms over here on the next one. They give us a definition, but in my terms it says an invisible line that a graph will get close to but will never touch. Simple as that. So imagine right now I'm a Jedi Master, and I ask Juan to come over, and he wants to like shake my hand, and he's going to be like, I can't reach him, Mr. Q. It's my invisible barrier. It's my asymptote. Does that make sense? Yeah? So today we're going to cover two of them, vertical, horizontal. The funner ones are these, diagonal, slant, and oblique. We're going to get to those next week. I don't want to, here's Whelm, I don't want you up here, so, okay? So with that said, copy this one, example 1. Example Q reads y equals 1 over x minus 1 plus 2. Super Q is y equals 1 over x. And mega Q, y equals 1 over 2x minus 3 plus 5. And get a coordinate plane to the side from negative 10 to 10. Give you some time, 1 minute. Go. So we're going to go ahead and start one step closer to where we need to be in regards to graphing. Today, with step 1, which is this one, I'm just going to show you how to graph our asymptotes. Okay? First, we need to identify them and graph them before we actually graph our function. Here it goes. Write your utensils down, look up to the screen. It's simple as long as you just step aside, admire it, like if it was like a Picasso. Here it goes. First thing I'm going to do with blue, instead of writing vertical asymptote, I'm just going to write VA. What does VA stand for? Vertical asymptote. Write that down and then write X equals. We need to come up with an equation. X equals. In red, I'm going to write what? Horizontal asymptote, but in short, what do I write? HA, and that one's going to be our Y equals. All right? So here we go. Look how easy this is. Look up to the screen, you're going to miss it. Here's our general rule. Our vertical asymptote is our H, is that correct? By looking at our equation over here, tell your neighbor what our vertical asymptote is, please. Everyone? 1. Because the negative is part of the rule, isn't it? So then write X equals 1. That is correct. Some of you are like, oh snap, Mr. Q. With that said, check this out. I'm going to go to my general rule one more time, and now I'm looking at K. Tell your neighbor what our horizontal asymptote is according to our new equation. Everyone? 2. That is correct. Write it in there. So now that we have 2 equations, we need to graph these, but pay attention to this part. Since they're asymptotes, they're invisible. So how can we indicate, Mr. Q, that they're invisible? Let me show you. X equals 1 is right here. To indicate it's invisible, I'm going to do a dotted line. You're like, aw, snap. Aw, snap is right. Which means our horizontal line at y equals 2, it's also a dotted line. And that's how you identify and graph your asymptotes. From 1 to 5, I'll come to right there. Yeah, 5, 5, 5. Okay, let's do super Q. Here we go. Once again, what is the first thing I write? VA, X equals HA, Y equals. So look at this one. Tell your neighbor what H is, or what our VA is. Does it have anything? So therefore, 0, that is correct. What is our horizontal asymptote, or our K? 0 as well, that is correct. So how do you do that, Mr. Q? Let's start with X. X equals 0, up and down, dotted line. Y equals 0. It's a horizontal line, so side to side. There you go. Not bad, not bad. All right. Here goes the challenging one. Here it goes. VA x equals HA y equals. Now this is a little bit different, just a tiny bit. Look up, please, or you're going to miss it. What do you guys notice here on the denominator compared to this one, everyone? Has a what? The 2. That means this one we cannot just use the 3 as our VA. This one we need to set equal to 0 and we solve for x. So what do? Add 3, 2x equals 3, divide by 2, x equals 1.5, and we write it at 1.5. And of course our HA is straight up what? 5. Okay, so let's plot that. 5 of y is up here. X is always up and down, so it's at 1.5 is about right there, 1.5. All right, so once again, what is the only difference from these to these? That this one we need to set equal to 0 and solve. But this one also works, by the way. Watch. Plus 1, x equals 1. And here goes the my superpowers. Ready? Here goes. Your memory is going to be like, what? Remember when we covered rational expressions that I asked you to find me the excluded value? What did we do? We took the denominator, set it equal to 0, and solved, didn't we? Why is it excluded? Because it's an asymptote. So with that said, copy these two. You're going to do these by yourself. B and C. Copy B and C by yourself. B is y equals 1 over 3x plus 9 plus 4, and C is y equals 1 over x plus 7 minus 5. Let's see how you do. All right, copy. All right, here we go. Oh. Letter B. Letter B. Did I tell you that story? I'll tell you that story some other time. VA x equals HA y equals. What's our vertical asymptote for B? Joel. -3. Yeah, you set that is equal to 0. Subtract 9, divide by 3. That's -3. And of course, our HA is 4. Hands if you got that. Okay. And of course, your asymptote. And -3 is over here. Up and down asymptote. There you go. Okay. Let's see our VA for part C. Jessica, x equals -7, and our HA is y equals -5. That is correct. So -5 down here, and -7 over here. Hands if you got that. All right. Now this is essential, guys, because this, let me show you really quick. Look up. Remember on the warm-up that we did the rational equation that looked like this and this, yes? And here's our coordinate plane. Well, guess what? Our coordinate plane was the asymptotes. So if we follow that, it moves around. Here's now our new coordinate plane using these asymptotes. My graph would be here and here. If we follow this one, it would be where? Here and down here. You're like, what? Yeah. So let's move on to the next part of the graphing. Ready? Here we go. Copy this one, example 2Q. This is going to be our last example. Y equals 1 over x minus 1 plus 2. I'm going to show you the entire process now on this one, put it all together. What we did on the warm-up with problem number 1, remember? We needed a table and then graph. But then part 1 was missing, which was the asymptotes. All right, here we go. So it says, graph the function, identify the domain and range. Don't worry about that. Let's first graph this. So how do we graph it, Mr. Q? Well, we start with our asymptotes. So I'm going to write VA, X equals, HA, Y equals. So with that said, tell your neighbor what X equals and what Y equals. Tell your neighbor, please. X equals what? Y equals what? X equals 1 and Y equals 2. That is correct. So Y equals 2 is right here. X equals 1, which is right here. Oh, right here. Okay. Step 1, hands, how do you feel with that so far? 1 to 5, 5, 5, 5. Okay. Step 2, make a table. Here we go. X, Y. That's why I gave you plenty of practice on the warm-up doing this. However, this one is a little bit tweaked. Look up, please. How do we tweak these, Mr. Q? Let me show you. Look up. Identify your vertical asymptote. All right, here it is. Look up, please, or you're going to miss it. It's going through this number right here. And I need you to choose 2 numbers from the left side and 2 numbers from the right side, and that's going to be our domain. So what 2 numbers am I going to choose from the left side? -1 and 0. How about from the right side? 2 and 3. And why don't I include 1? Because 1 is undefined. You're like, what? I know, right? Let's write it out. -1, 0. I'm going to write 1 undefined, 2, and 3. All right, how do we get our values? Well, we substitute them in here. Here we go. Y equals 1 over parentheses minus 1 plus 2. I'm going to write several of these so we can go a little bit faster. All right, let's start with our first value, -1. What is -1 and -1? -2. So that gives us -1/2 plus 2. So what is 2 minus 1/2? 1.5. Next value, 0. 0 minus 1 is -1. So what is 1 divided by -1? -1 plus 2, which is 1. Next, 2. What is 2 minus 1? 1. 1 over 1 is 1 plus 2. That is 3. And the last one, 3. 3 minus 1 is 2. That's 1/2. So what is 2 and 1/2? 2.5. Let's graph that. -1 and 1.5 is right here. 0, 1. So this is part of my graph on this side. Let me do the other side of the undefined. 2, 3. And 3, 2.5. And that's my other side of the graph. Woo-wee! Let's go! Oh yeah, we got this. From 1 to 5, welcome to Barry up to right there. Yeah, 5 4s, 5 4s. Have a good one, guys. Home play I'm going to upload in a little bit. Go to the rational functions module. See you guys tomorrow. Bye.